Hey SM2, this week we're going to be covering 3.3. We're going to continue with learning how to graph quadratic functions. Last time we talked about, in 3.1 and 3.2, we talked about graphing functions, quadratic functions that look like f of x is equal to ax squared. This meant that you had stretches or shrinks. And if a was negative, then you had reflections, right? And then we also talked about how to graph f of x is equal to ax squared plus c, where we contained all the stretches, shrinks, and reflections, but we also talked about how c shifts the graph. So this is a vertical shift, up or down. And we talked about how that works. This time around, we're going to be talking about graphing in the form ax squared plus bx plus c. And then we also, so these are still going to be quadratic functions, but these quadratic functions aren't going to be on the y-axis. They might be moved to the right or to the left, up or down, and they could be anywhere. Okay? And so the vertex might be in a different location than other than on the y-axis. And so the question we want to answer today is, how can you find the vertex? So how can you find the vertex of the graph when it's in this form? Okay. So let's define some vocabulary first. So notice that whenever we have quadratic functions, again, they're U-shaped, so they look like this, or they look like this if they're reflected. If a is positive or greater than 0, it looks like this. If a is negative or less than 0, it looks like this. So a maximum value, you could say, is the highest point. It's the highest point of the function. Or you should say, because that more describes like the vertex, you should say the highest y value. The highest y value of the function, while the minimum value is the lowest y value of the function. Okay? So let's look at a quadratic function right here. So this is a graph in the form of a quadratic function in the form of f of x equals ax squared plus bx plus c. So it looks like this right here, and you can see that the y-axis is right here, and our vertex is not located on the y-axis. So notice here that the graph opens up whenever, as we set up here, the graph opens up when a is greater than 0. And the graph opens down when a is less than 0. So a meaning this value right here. If the value in front of x squared is greater than 0, it opens upward. If it's less than 0, it opens downward. Okay? The y-intercept is right here. Okay? So the y-intercept is 0, c. So that means, again, intercept, this would be a point of x, y. So the y value would be c right here, and the x value would be 0, because at the y-axis, the x value is 0. Okay? The x-coordinate of the vertex, well, we already talked about that last time. The x-coordinate of the vertex is the axis of symmetry. Okay? And the axis of symmetry is found right here. There's actually an equation that we can use to find the axis of symmetry. So here is the axis of symmetry, and here's an equation for it. So the equation is x is equal to negative b over 2a. So negative b meaning this value right here, and a being this value right here. So let's look at this, and what do we notice about the x-coordinate of the vertex and the axis of symmetry? So the x-coordinate of the vertex and the axis of symmetry. So the x-coordinate of the vertex is the axis of symmetry. So that's what we should notice, is that the vertex, which is in the form of x comma y, so vertex is x comma y, and x, which is the x-coordinate of the vertex, is equal to the axis of symmetry. So we already talked about this a little bit last time, but the x-coordinate was always 0 and the axis of symmetry was always at x equals 0 because we were always on the y axis. This time we are not on the y-axis. So pretty much this is the vertex of x comma y. This value right here, axis of symmetry, which is x is equal to negative b over 2a. I guess you can write that in this column over here, the process, if you want to find the axis of symmetry or the x vertex, you can just say axis of symmetry x is equal to negative b over 2a. Okay. Now let's talk about evaluating the function f of x for x equals 0. So if f of x is equal to ax squared plus bx plus c, what does that mean when x is equal to 0? So if we look over here, this is the x axis right here, so you could say this is negative 1, negative 2, negative 3, this is positive 1, positive 2, positive 3, so that means this value right here is x equals 0. So what do we know about the function right here when x is equal to 0? So let's plug that in. So if we do f of 0, we get a times 0 squared plus b times 0 plus c. Well, 0 squared is 0 and a times 0 is 0, so that cancels. B times 0 is 0, so we're just left with c. So what I'm trying to say here is that when x is 0, which is the same thing as the y-axis right here, this is when x is 0, we get the c value. We get c, which is why the y-intercept is always x, which is 0, comma c. So your y-intercept is always going to be c, because whenever you set x equal to 0, these cancel out, and then you get 0. Okay. So now let's talk a little bit more about the minimum and maximum values that we were talking about earlier. So the y-coordinate, right here you can see the max and the minimum value. And remember how we talked about up here, we defined the maximum value as the highest y value and the minimum value as the lowest y value. So if a is equal to 0, if a is less than 0 in your function, you're going to be open downward, which means you will have a highest y value, and we call that y value the maximum. So you see here, the y-coordinate of the vertex of the graph f of x equals ax squared plus bx plus c is the maximum, or you can just say max, of the function when a is less than 0, or the minimum of the function when a is greater than 0. Okay, so basically what we're saying is, before we talked about the x of the vertex is your axis of symmetry, while the y coordinate of the vertex is the min or the max, depending on the value of a. On the value of a. So right here, this is the maximum value, which is also the coordinate, the vertex of x comma y. So maximum is a y value. So right here, this is the y value, right? We're talking about a y value because it occurs on the y-axis. Well, that right there, the maximum is the y value of your vertex, while the minimum is also the y value of your vertex, but when a is greater than 0. So if you want to process when a is greater than 0, there's a when y is greater than 0, there's a minimum. When a is less than 0, there's a max. And the min and the max are the y values of your vertex. So let's do some extra practice problems. So it says in exercise 1 through 4, find the axis of symmetry and the vertex of the graph and the vertex of the function. Okay, so to find the axis of symmetry, there's an equation. The axis of symmetry is x is equal to negative b divided by 2a. Okay, so a is the value here. This is a. This right here is b. And this is c. So a is equal to positive 1. Because there is no nothing right there, so that means it's just 1. b is equal to negative 10. Right there it's negative. And c is equal to 2. So let's plug that into our equation. So we know the axis of symmetry is x is equal to negative, never forget that negative, negative b divided by 2 times by a, which is 1. Now, something that's going to get everybody wrong here is a lot of people forget this negative sign out here. So what I like to do is think of it like this. We know b is negative 10, but because there's a negative sign out here, just think of it like you're doing the opposite of b. So if b is negative, I'm going to write just positive 10 instead of writing the negative, divided by 2 times by a, or times by a, which is 1. So I know here that x will equal to 5, which is the axis of symmetry. So this right here is the axis of symmetry. Now it wants us to find the vertex. So here's the thing. We know the vertex will be 5, because that's the axis of symmetry, comma something. We don't know that value. But we can find this value right here, the y value, by plugging in the x value of 5, because we know that the vertex is at x equals 5. And so if we plug in 5 into our function, we can find the y value when x is 5. So let's do f of 5. And that's going to equal 5 squared minus 10 times by 5 plus 2. So that's equal to 25 minus 15 plus 2. And that's equal to 10 plus 2, which is equal to 12. So when x is 5, y is equal to 12. So our vertex will be 5, 12. Alright. And the thing is, here we know that this is going to be a minimum value This will be a minimum value because A is positive, so we're open upward. Okay? So go ahead and do the other examples. Remember here that if you want to outline a process for this, for your process will be to use x equals negative b over 2a to find axis, then plug x value, or the axis, into function to find y value. And that's how you would do both parts A and B for exercises 1 through 4. Now let's go to exercises 5 through 7. So it says to graph the function, describe the domain and range. So we have functions right here in the form of ax squared plus bx plus c, and we need to graph the function. So for number 5, we know that a is equal to 3, b is equal to 6, and c is equal to 2. So let's first find, like we did up here, let's find the vertex. So the vertex is x is equal to negative b, which is 6, divided by 2 times by a, which is 3. So x is equal to negative 6 over 6, and that's equal to negative 1. So I know I'm going to be at negative 1 for my vertex on the x-axis, on the x value, so let's plug in f of negative 1 to find the y value. So that's equal to 3 times negative 1 squared plus 6 times negative 1 plus 2. So 3 times by negative 1 squared is just going to be 3. So I know it's going to be, so f of negative 1 is going to be 3 minus 6 plus 2, so that's going to be equal to negative 3 plus 2, and that's going to be equal to negative 1. So my vertex will be at 1, negative 1, or negative 1, negative 1. So right here, if I draw my y-axis right there, and my y-axis right here, like that, my x value, my axis of symmetry, is at negative 1, and my vertex will be at negative 1, negative 1, so right there. And we are open upward, so I know we'll be facing upward because a is positive. Okay, and we know that we're going to have a stretch of 3 right here. So if I plug in 0 into the function, for this right here, I'll find the next point over. So I want to find the next point to the left and to the right. So if I plug 0 into the function, I'll find the y-intercept, because this is the y-axis. And remember that the y-intercept is always c, right here. So I know that my intercept will be right here. And this is a symmetrical graph, so that means my point will be right over here on the left side because it's symmetrical. And there you go. That's how you graph it, like that. And now we want to describe the domain and range of the graph. So the domain, we can see that we will cover all x values because this function will go to the negative infinity direction in the x and the positive infinity direction on the y. So the domain, you can do negative infinity to negative infinity, or all real numbers. So you can use that sign right there. Now the range won't be quite the same. So the range always starts, or finishes with max or min. And remember that the range and the domain are always written from lowest to highest. So the lowest value would be right here. And that's going to be the minimum value, and that's the y value of the vertex. So that's going to be negative 1. And we go to positive infinity on the y. So 1 to positive infinity, or you could say y is greater than or equal to negative 1. Alright, feel free to try 6 and 7 using the same steps I did. So if you want to use a process, like right here, I would just say find vertex using the methods that we found here. So using this process right here, find the vertex, and then 2, you can find the y-intercept. You can find the y-intercept like we did over here to find another point on the graph, and then use symmetry to graph the rest. So 3, use symmetry to graph the rest. Okay, and don't forget to write in your domain and range. Okay, so for exercises 8 through 13, tell whether the function has a minimum value or a maximum value, and then find the value. So for number 8, we can see here that a is equal to negative 1, or negative 1/2, sorry, and that's less than 0, so that means our graph will be open downward, so we will have a max value. So we'll have a max. So we know we'll have a max value, but what is that max value? So we only know how to find the max value by first finding the x value, or the axis of symmetry, and plugging that in. So the same steps that we used up here. So if we want to find the max value, first find the vertex. So x is equal to negative b over 2a, and that's equal to negative, b is negative 5, divided by 2 times by negative 1/2. And that's going to be equal to so negative and negative, so negative and negative, that's going to be positive 5 over 2 times by negative 1/2 is negative 1, so that's equal to negative 5. So we know x is equal to negative 5 for the vertex, and now we can plug that in to the function. So y is equal to negative 1 over 2 times by negative 5 squared minus 5 times by negative 5 plus 2. So that's equal to 5 squared is 25 divided by negative 1 over 2. That's negative 25 over 2 plus 25 plus 2. So to do this, we need to add fractions. So these two and these two right here, well, that's the same thing as, you can write that as negative 25 over 2 plus 50 over 2. So that's going to be still 25 over 2. So 25 over 2 plus 2 over 2. So, 4 over 2, because that's the same thing as 2, so 4 over 2, so that's going to be 29 over 2. So that's equal to 29 over 2. So that right there, we just found the y value when the x is negative 5, and that's equal to 29 over 2. So we just found the max value. So the process here would just be follow the same process that you used through 1 through 4. Just find the y value, and that is your minimum or your max. Alright, so for this right here, this is just a stored problem. So it says the function h is equal to negative 16 t squared plus 250 t, and it represents the height in feet of a rocket t seconds after it is launched. The rocket explodes at the highest point. So basically what it's saying is that you have a function, and here's the graph for the function, and it's modeled by this right here. So it represents the height. So this represents the height, and this represents seconds. So if you launch the rocket, it's going to explode right there at the highest point. So when does the rocket explode? So basically what it's asking is what is the max value? So we know how to find the max value. First of all, we need to use the form x is equal to negative b over 2a to find what time right here in seconds when the bomb explodes, and then we can plug that into the function to find the height at that time. So it's equal to negative, so b in this case is 250 over 2 times by negative 16. So if you find the x value, you find the second at which the rocket explodes, and then you use that to plug into the function to find the height at where the bomb explodes. So when does the bomb explode? This is time. Sorry, I wrote that wrong. It's not what is the max value. This is pretty much asking for what is the axis of symmetry. So like right here. This is the axis of symmetry. And then at what height does the bomb explode? This is what is the max. So I'll let you guys do that on your own. Hopefully you can find the answer. Let me know if you have any questions. But that should pretty much do it. I'm trying to organize my notes a little bit better. So if you guys want, I encourage you to write down here a summary of what you learned. So whenever you go back and use your notes for your homework, you have something to refer back to, using your own words to help you find answers. So hopefully that's it. Let me know if you have any questions. You can email me. If not, I'll just see you back in class. Thanks, guys.